Okay, we are going to look at our first page of our circle book. I intend to, on this circle book that you've made either in the last video or you're writing this on a piece of paper, which is totally fine, I am just going to put some of my vocab right here in this book. So I've moved it in a little bit. It's just whatever you want to do is the first page. So we're going to start with what a circle is. So we've got definition of a circle. Okay, so this is a circle, and if we had, let's say, the center right here, and we can call this, I don't know, circle P. Call it whatever you want, though. It is the set of all points that are equidistant. You guys know what equidistant is? Equal distance, just like it sounds. It's just a fun word. Equidistant from a point called the center of the circle. Okay, so I'm going to zoom in just a little bit on that. The set of all points that are equidistant from a point called the center of a circle. So all around on this outside line, there can be points, and they're all the same distance to the very center of whatever point we've named our circle. Okay. So the next one we're going to talk about is the radius. So a radius looks just like this. It's from that center of the circle to the outside. That is a radius. Okay. A segment that connects the circle to the center of the circle is what we're going to call it. Segment that connects the circle to the center. Okay. Now we're going to talk about a chord. Okay. So a chord, I'm going to move to this side. Remember, you can always stop the video and freeze if you didn't get all of it. We've got a chord. So it's spelled C-H-O-R-D, like a chord you play on the piano or in music, but that is not what it's for. It's a chord that passes through not passes through, a chord that, yay, it's like real time, that connects, chord is a segment, there we go, I got it, I promise, a segment that connects 2 points on a circle. There we go, that makes more sense than what I was saying. Okay, segment that connects 2 points on a circle. 1 point on the circle to the other point on the circle. It stops there. It's a segment. It doesn't go all the way through. It doesn't touch the outside. It must be inside the circle going through those 2 points. And then we've got a special chord. So this chord goes from one side all the way to the other and goes through the center. That's called a diameter. And a diameter is a chord because it touches both sides of my circle that passes through the center. Passes through the center. Okay? So we know that a radius is half of a diameter. Okay, so a diameter is just 2 radiuses connected. Goes through the middle, but every diameter is a chord. It's just a chord that passes through the center. It's just got that special part to it. Okay, so we are going to talk about a little bit of a relationship between a chord and a radius. So I'm going to draw this other picture right here at the top. So I've got a chord, and then I have a radius that comes up and meets that chord. Okay? Now, if my radius comes up and meets that chord, we have something special that's going on. If it meets at a right angle, all of a sudden, I can kind of draw in these sides. Do you guys see that I have two right triangles? I end up with, these two triangles end up being congruent. They share the side. It's an isosceles, okay, because they meet at the same spot. So these two sides are the same. So then these two angles are the same, which ends up making these two sides the same, that I'm putting little marks on them to show that they're equal. I put the little 3 marks there showing they're equal, or the 1 mark showing that it's equal for this side and it's equal for this side. So I end up doing this, which is really good in some pieces because I can use Pythagorean theorem. So if I have 2 out of the 3, it makes my life really easy and I can figure this out. And this all is about the radius and the chord meeting at 90 degrees. So we're going to put that down. If the radius meets a chord at 90 degrees, then the chord is split in half at that point. So we've got it, splits right here. Both those two sides are equal, and we can solve other sides by using Pythagorean theorem. Solve other sides using Pythagorean theorem. And I'll give you some examples on your packet when you look at that video. Pythagorean, sorry about the spelling, theorem. Okay, so that is the first page, and I'm going to go over it one more time real quick. We know the set of all points that are equidistant from a point called the center of a circle. Okay, so this center is equidistant to all the points on the outside. A radius is a segment that connects the circle to the center. A chord is a segment that connects 2 points on a circle. And a diameter is a special chord that passes through the center. We also know that if a radius meets a chord at 90 degrees, we have split that chord in half. Therefore, we can draw in other lines to show that we have 2 right triangles. So we can use Pythagorean theorem to find other sides. Okay, and we're going to do an example like that. So that is page 1.